Hello everyone, Bri the Sky Guy here from A Time for Science with the latest edition of Eyes on the Sky in Eastern North Carolina. Today we're going to be revisiting the galaxies to be found in the spring skies. Last time when we discussed galaxies, we were looking at the Leo triplet in the constellation Leo the Lion. We saw an incredible system of multiple galaxies spanning millions of light years, but we never really talked about what a galaxy is. So a galaxy is essentially a large collection of stars. They're really the largest collections of stars there are in the universe. Galaxies are the basic building blocks of the universe. And our universe, or at least the visible part of it, is made up of trillions, tens of trillions of galaxies, each one of these galaxies containing hundreds of billions, if not trillions of stars themselves. Among the stars in a galaxy, you'll also find large amounts of gas and dust, planets, moons, comets, and asteroids. And the springtime offers us the privilege to appreciate and study this most basic and important aspect of the structure and nature of the universe. So let's go ahead and dive in. As we look to the galaxies this time, we will be gazing towards the constellation of Virgo. So to find Virgo, you're going to want to start at the Big Dipper. So you take the three stars of the handle of the Big Dipper and follow them outward. Follow the curve by arcing to Arcturus, the third brightest star in the sky in the constellation Boötes. From Arcturus, you then spike to Spica, which is the brightest star in the constellation Virgo, and there you are. Virgo is the second largest constellation in the sky. It's made up of about a dozen primary stars. And Virgo is usually associated or depicted with angel wings or holding a stalk of corn or wheat represented by the star Spica. Virgo is home to something pretty incredible, the Virgo supercluster. This is a massive structure of approximately 2,000 galaxies. Here we see a beautiful deep sky image of just a portion of this cluster. And the dark spots you see in this image indicate where bright foreground stars were removed. So everything else in there is essentially a galaxy. And we'll spend a few minutes exploring just a small sample of the galaxies available here. But do remember that the Milky Way and our local group of galaxies is just one small neighborhood in this galactic city that is the Virgo supercluster. The Sombrero galaxy is our first target. It's found in a string of galaxies just at the southern end of the Virgo supercluster. And the Virgo supercluster kind of is found all within this region of Virgo, kind of right through the heart of the constellation. And looking at the Sombrero galaxy, to find it, you look towards the constellation Corvus the Crow. You can use this star right here, the star Algorab in the constellation Corvus. The Sombrero galaxy will be about 5 degrees to the northeast above this star. So that's one way to find it. You might have to dig a little for it, but not too bad of a target because this is one of the brighter galaxies out there to observe. So good for amateur astronomers to look at this thing with an 8-inch telescope or so. You can see it with smaller scopes and binoculars, but if you want to see some of the detail that's provided with this thing, bigger is better. Now, the Sombrero galaxy is a very interesting galaxy. It's marked by a very bright, dense core or central bulge, and that structure there is surrounded by a large disk of dark gas and dust. And we'll see that as we zoom in to our target here. Get a little closer. And the Sombrero galaxy might look like a spiral galaxy, but it's a galaxy of a different type. It's called a lenticular galaxy, which means that it's kind of like in this intermediate phase as far as galaxy evolution goes. It's kind of like a stunted spiral galaxy that has little to no star formation occurring in it. It's really still a mystery as to how these lenticular galaxies actually fit into the overall story of how galaxies evolve over time, but they do seem to be this strange transition state, whether it's from being elliptical to a spiral or a spiral to elliptical. There's some interplay going on there, and most likely galactic collisions are involved in these types of galaxies. So just one more thing to ponder as you stare off into the depths of the night sky. Now we move on to a real beast of a galaxy, M87. M87 is found at the heart of the Virgo supercluster, and it is massive. It's classified as a supermassive, supergiant elliptical galaxy, and as we zoom into it, you can see just the huge number of other galaxies surrounding it in the Virgo supercluster. So one of the real standout things about M87 is that it has an active supermassive black hole at the center of the galaxy. And that black hole is feeding on matter and shooting out a huge beam of relativistic particles into intergalactic space. And what that means is that essentially as that matter is falling onto the black hole, there's just not enough space for all of it to reach the black hole at the same time. So some of it gets violently ejected out in these narrow beams of particles traveling nearly the speed of light. That's what relativistic means. Speed of light, things happening at the speed of light. So pretty intense stuff, to say the least. Now, this supermassive black hole was in the headlines last year when scientists took the first resolved image of a black hole. It was big news for a couple of reasons. One, because it was just awesome. And two, because it allows us to test our understanding of the universe in a very dramatic fashion. So we have strong confirmation of general relativity working when applied to smaller objects like the Earth and the Sun, but not so much when it comes to incredibly dense, massive objects like black holes. So these images will allow astrophysicists to measure several different properties of the black hole and to not only verify Einstein's general relativity, but also gain insight into the formation and behavior of black holes, which is something we don't have much working with except for our mathematical understanding of how these things should work. And a lot of that stuff does line up pretty well, but the closer you get to a black hole, the more things just get really weird, and we don't have much in the way of verifying that weirdness, but these new images do give us a tool to investigate that, along with the gravitational wave detections that we can make now as well. So it's almost like there's this whole new world of observations being made that can hopefully rattle our understanding of how the universe works. Well, that's all for this edition of Eyes on the Sky in eastern North Carolina. Don't forget to watch those sunsets now. Catch Venus out there towards the west above the setting sun. It'll still be out there for you to enjoy, so don't miss that. But until then, y'all have a great week. Keep on looking up.